Qt webinar. My name is Nils Christian Rascher Nilsen. I am a sales engineer working here in our Oslo office, Oslo development branch of Qt, DGA. And today, my colleague Gabriel at my side will take you on a little deep dive into the Qt Quick and Qt Quick components set of Qt. But before we get started, just some practical information. I will be monitoring the chat and the Q&A. So if you have questions during the session, feel free to ask them in the chat, but make sure they're not only to the host, because then they will not be answered. Direct them to me or to all the panelists. Also, we will be recording the session, and we will send you all a link to the recording and answers to all the questions after this. So most likely by tomorrow morning sometime. So we will be recording it. You can download it. Feel free to share it with your friends and family or colleagues or whoever might be interested in this topic. So if you're not logged in, or if you don't have the time to stay for the whole while, don't worry, you can catch the rest of it. I think that's it. If you let me just start by giving a quick introduction to DGA and why we are the ones doing this. So DGA, Qt, we are now the same organization that used to be Trolltech, that used to be Nokia. We have been developing the Qt framework for 20 years actually now. In March 20 years ago, the company Trolltech was founded, and they started development of the Qt frameworks here in Oslo. Qt is, for those of you who don't know, a cross-platform technology. It is a well-proven C++-based technology for both UIs, but also for the full application logic and for all of those other tidbits of your application that are not UI-specific. And I think Gabriel will show us a little bit, not just about the UI, but how we're building the logic, etc. as well later. Well, I don't think I need to say too much. This is going to be a fairly skilled session that you need to know some things about Qt, but don't worry. If you feel that there are parts you don't understand or don't know in this session, we also have other webinars where we will be able to explain the more easier or lower level questions or topics about Qt. And also feel free to contact us if there are questions unanswered after the session. And yeah, without much further ado, then Gabriel, the scene is yours.
Thank you, Nils. Hi, so I'm Gabriel Lidite. I've been working on Qt since, well, I'm a software engineer, and I've been working on Qt since 2009, first in Nokia and then DGA. I've been part of the UI team, and I like to, let's say, fix pixels so that they look as they should. More recently, I've been working on the Qt controls module, which I'm going to present today, and I'm also part responsible of the Qt board. I live and work in Oslo, in Norway, which allows me to be in among one of the first, some of the first Qt developers, which is cool. And yeah, as you can probably hear from my accent, I'm not native speaker. I'm half French and half Spanish, so you will have to bear with me if I do some grammar mistakes.
I don't think that's going to be a problem.
Yeah, hopefully. So yes, as Nils reminded, this presentation requires that you know some QML and some of the basics of Qt itself. But don't worry, we will try to. You can always catch up later, and we'll try to make this presentation interesting for you nonetheless. So today we're going to see how to implement an UI with using controls, how easy it is to do that, how to interface QML with C++ and the other way around, so that we can bring some logic into QML. Well, QML is supposed to be UI mostly, but we can have this interfacing so that we bring some other more computational, more complex calculations into QML, and also how to create models so that they are QML compatible with all those list views and such. So to start with, here is a UI, the UI that we're going to implement today. You can see this main window. This main window has a toolbar, and then the contents of the main window is split in two. On one side we have an image view, the other side we have a tab view. The tab view also has some contents. This has a table view, and then the other tab not seen here, but now yes, we have a custom view. So the small application implements a histogram. Histogram being, well, what you can see, it's more apparent from the second tab, the custom view. It's basically counting how many pixels have that intensity within the image and separated by the three channels. Okay, so let's start with it. So when you launch, well, I guess you all know a bit about Qt Creator, and so when you create a new Qt Quick UI application, what you get from the beginning is something like this. It's a template, and it already runs. It already does some things, and we run it. You can see that we get a Hello World window with a Hello World button. We can click this button, and it works. What we're going to do is start implementing this our UI. So we remember that we had a split view as a top level view. This split view obviously is filling the whole window. So this split view had two views, one image view. This we're going to use only a plain image, and also a tab view. So tab view is tab view in Qt Controls Wall, and it had two tabs. The first tab had title as table, and the second tab was our histogram. Change the title. So at this point, if we run it, what we see is we already have this table, this tab view, but the split view is not working because the image is not there, so it doesn't have an implicit width or anything. So we're going to help it a bit. There's another module. Right now we're using only Qt controls, but you can import Qt Quick layouts that allow you to lay out and insert, let's say, size constraints into items. We will see a bit more in a bit more detail later how layouts work, but here we can say that we want that our image minimum width is going to be 200 pixels, for instance, and that our tab view layout minimum width is going to be 200 pixels as well. Now if we run, we see that we have this minimum, the image on the left, there is an image showing yet, but it will come soon, and the tab view also has a minimum width of 200. So this is working. As you have seen, there's a bit of margin spacing, so we're going to add them. So to do that, we are going to just wrap the tab view in an item and set the constraints, the size constraints on the item, and add these margins here. So on the tab view itself. So we're going to fill parent and add some margins around. Of course, margins. Oh, since well, this is on Mac. Maybe on other platforms we have other margins. We want to respect other margins. So we grab this small snippet here, so you can support other platforms. And we like 12 pixels on Mac, and we like maybe smaller margins on Windows, for instance.
So even though this is a completely cross-platform UI that can, of course, be compiled and run on any of the platforms we support,
absolutely,
here you show an easy way of actually making it slightly different on those platforms.
Yeah, for instance, yes, exactly. Yeah, but remember that this is Qt, and we support all the platforms and all as much as we can native look and feel on all the platforms we support. So this tradition, so to speak, has continued in Qt controls. So now, as you can see, we have this margin around, and it's looking already like very much like the UI we wanted to implement. We can finish tweaking some things here, like updating the title, maybe setting a wider window. Let's see how it looks when looking as it should. Let's do the toolbar. So the main window, this application window, has a toolbar property to which we assign a toolbar object. The toolbar object is just a container. So we can add a tool button and say that the icon source, this has been populated. So we have already in our resources a document open icon. And here it is. So this is our toolbar, and we have an icon. And remember that our UI had a slider as well. So we had a slider. Let's run it, and oops, but we see
that's what it's supposed to look like.
Exactly. As I said, the toolbar is just a container. It's a bit dumb container. So we're going to use our layouts here and put everything inside a row layout. We could have used just a plain row, Q-quick row, but layouts allows us to do two nice things. First, as we saw before, they allow us to define a minimum weight or maximum weight as well. And they also properly align controls. They know some internal properties of the controls, and they align them properly so that they look nice. So we can continue with our toolbar, with our slider, sorry. So the minimum value, let's say it's 1, maximum value, default value, we can assign it to 6. Remember, we wanted to see the tick mark, so that's organic. And we also want to snap every single unit. And what is this looking like? Okay, so we have a slider that is working. Let's see now how do we react to the UI. For the tool button, for instance, we have an unclicked, a bit like the mouse area. So if we connect to the unclicked signal of the tool button, then we can say, okay, tool button clicked. We run it, and yes, we have it, it's working. But remember, this is our open file tool button. On menus, we will also like to have something in the file menu. So we would like to add menu item here and say that the menu item is going to be open. And then on triggered, then we want to do the same, right? Some action. So this is not tool button clicked, but menu item triggered. Okay, so we click the tool button, it says tool button clicked, we trigger the menu, and this is menu item clicked. But you can see that it's the same action in the end that we want to do. At the end, we will want to open a file and assign it to somewhere, and so on. So instead of duplicating code and data, we have this action object. And basically we can do the same. So we can set the text, we can set the icon source, we can react on trigger. So now, sorry, so we have an action. Now we can reuse this action on our menu item on a tool button, and actually we can reuse actions in other places too. But let's call it file open action. And so menu item will just take this action and we will assign it to it. And the same for tool button. We don't need all this anymore. Let's run it. So we click the tool button and we have action trigger, and we open file open and we have action trigger as well. So
Quite nice.
quite nice.
Very neat.
So let's add a bit more logic to it. So right now we have, as you have seen, sorry, let's launch it again. And we have seen, we have most of the skeleton of the application. There's a thing missing, there's no content, but we're going to start adding content. Let's open an image. We also have in Qt part, more or less part of Qt controls, the dialogues module. This allows you to define, for instance, a file dialog. And let me copy this. And assign a folder to it, and then do something once we accept the file dialog. So the image view that we want to assign to, let's add an ID here. So what we're going to do is, when the file open action is triggered, we're going to do file dialog. But open, once we have accepted the file dialog, then we are going to assign to the image view source the file we have selected. That's right. So we know it's the same, so we can click here and select this image. And there it is. We have our image.
Very nice.
Very nice. Yeah, this is one of the nice things of living in Oslo, by the way, that get there very soon, very quickly after work. If you have a stressing day, you can get to places like this. But
I don't know if this image is scaling.
right, no, yeah, you're right. You're right. I need to fix this fill mode. Let me add it here. There. Okay. There we go. So we have our image, and you see how things are working as expected, right? If you move the splitter separator, the split view separator, then things resize accordingly. If you resize the window, things resize accordingly. Everything is working as we expect and naturally.
Yeah. The only downside right now is that obviously on Gabriel's Mac, this is resizing and scaling quite smoothly, but unfortunately over the internet connection that we have over the webinar tool, things tend to lag a little bit. So if this seems like a laggy resizing, that's not Qt's fault, unfortunately.
Indeed. Indeed. But you can try this at home and see that it's working. So let's continue with our UI. Remember that we have to show a table view. Okay. So table view is a table view, and it has columns. So we are going to add table view column. We had one column whose title was just a sharp that stands for number. This is how we're going to display our histogram values, basically, once we have computed the histogram on the image. So green and blue. Let's run it. And we have a table view already. It's looking pretty decent. Again, we are on Mac, so we're going to add this these margins a bit here in the temp. We can also tweak the columns width. We know that this will never need much more than 45, so we can 45 pixels width. This may need a bit more width. So let's try this. And there we go. So we have a perfectly normal table, except that it doesn't have any contents. But you can do things like reordering columns or well, scrolling where we have content. But this will come later. Now, and remember, we can open our image and show it. So our UI is mostly done. What we need to do now is do something, add some logic, right? Because we have this image and we need to we want to compute the histogram of this. So before we jump into C++, let's try to think it. If I had an image and I wanted to calculate the histogram, what would I like to have? In fact, we're trying to think how we would like to use the histogram and then try to infer an API from that. So we know that we will have our image source because we need to pass the image to the histogram. This happens to be the same image that we are displaying, so we can reuse it. We'll have a bin count. This is so that we can have a finer or coarser histogram calculation. It takes the same, but sometimes we want to process less data or more data. So here we're going to use our slider. Oh, a slider which I forgot to give an ID to. So it's going to be bin count slider. So the value. So each time we increase, the value of the slider is going to multiply by 2 the bin count up to 256. Also, let's go a bit further. We want to compute the histogram because the image can be large, and we don't want to maybe compute it immediately after we change the image source or the bin count. It can be because maybe we are setting up everything, and then we'll have 2 computations set when only one is necessary. So, okay, in this case, we can do this on image source changed, and then say it's called compute. Or we can do the same on bin count change. Oh, sorry. Let's spell this. Bin count change. And then call compute as well. And maybe it can take a long time, so we want to react when the histogram is completed, right? So on histogram, update it, and then histogram. Thank you.
And yes, this is live coding, so there might be and there will be spelling errors, etc. So, but that's just proof that it's all real, so to say.
Yeah. So this is more or less the API. So from here within, we have 2 properties: image source and bin count. We have sort of a function we want to call. We have a signal we want to listen to. Actually, well, we can just display that, yeah, okay, we computed the histogram, but this is not very useful per se. But maybe we want to display the first, the values for the first bin in the histogram. So, or do some some computation on this later, or quick something. We want to access basically the data in a histogram. So let's say something like this. So again, we have these 2 properties, image source and bin count. We would like to have a compute sort of function that we call, but also we have functions that return values. So this compute, for instance, could be a slot, as we know. But this return is not a slot, right? Because they return some value. So we're going to see how we do that. But basically, it's going to be like this. let's go back quickly to the presentation. So what we're going to do is define our class RGB histogram that inherits QObject. Properties are just Q properties inside C++. Also, signals and slots map directly to QML, so we don't have anything to do. But for this function readCount, for instance, you see that we need to add this Q invocable. This makes sure it's visible from QML. So let's do it. So what we want to add is a new C++ class. We're going to call RGB histogram. Base class is QObject. We're going to do QObject. Let's put it to the right place. And done. And so, as we said here, also not this part here. So, Q property. So, image shows is a QURL. Image shows. And another Q property. Int for bin count. What did we have? Oh yes, signals, so void histogram updated. And slots, we have this compute function. And so yes, remember this key invocable, sorry. Int readCount, int bin, for instance, and so on. Actually, I had this prepared in advance so that we don't spend too much time, but I guess you get the idea. One of the nice things also about Creator is that there's not much code you need to write. Creator can help you. For instance, you have this bin count property and you want to generate. You want Creator to help you generate all the functions that we're missing, right? So you can right-click on Q property and on the context menu go down to refactor and generate missing Q property members. And voila, Creator will do that for you. That's one of the nicest things of using Creator because it's pretty much very tightly integrated with Q. But what we're going to do is fire up the cheat file and copy paste the contents. There we go. So we see, well, we added an extra property we will need for later. Well, we need for histogram view. But basically, you can see it's pretty much straightforward. Our RGB histogram has nothing, but for Hist2 we have the contents.
A little pre-created cheat file there.
Yes,
the functionality.
It saves a lot of time in this presentation. I hope our public doesn't mind that we take this kind of shortcuts for this. But basically, you see how it works. We have this is a compute function, and we do other computations going through the image, and at the end we emit this histogram updated signal, and that's exactly what we want. So, but before we can use it, we need to make it known. Now we have defined the class, but we need to make it known to the QML engine. To do so, well, first we have this main.cpp file. This main.cpp again it's part of the project template. So it will be created for you, and you don't need to have anything. So we are going to register type here, RGB histogram. This is our type. Then obviously we need to include also our histogram, and then we need to do some import URL. So let's call it a big corp. And let's say we have an image. It will be our own image analysis module. Version is 1.0. And we want this to be visible as RGB histogram. This is the type name in QML. And that's basically all we need to do. So let's see. Let's go back to our QML file. So remember, yes, we have a histogram here, and it looks like, unless I made a typo, it looks like the API is conformed to what I had there, but we also need to import this com.bigcorp.image, this is 1.0, our module. So remember, import statement is mapped here in this schema register type, and the type name, the RGB histogram that we're using here, is mapped here. So let's try it. Compiling, very well. We open the image. Oh, and victory! We have a histogram and some values from our histogram. So it's working.
Not bad.
Not bad. Not bad for some live code. Well, let's finish our UI. Remember that we had a histogram view, so we're gonna use this RGB histogram view that we have pre-programmed. We can see in a minute what it looks like. Obviously, we need to pass it the histogram so it can display it. Let's call histogram is. So this is going to be a histogram, and let's open it. Let's open this, and here it is. This is a histogram, and let's see if so. We saw that opening an image changes the histogram. What if we set another image? Oh, different histogram. Good. And if we change the bin count, we see that the histogram gets finer and finer. So, well, I guess our UI is almost done. There's only this table view. It's a bit sad because it has nothing to show. So we're gonna give it a little hand. Here also, sorry, I wanted to add these margins. But let's give a little hand to our table view. Let's suppose that what I'm going to do now is a hack. It's a sort of, don't do this at home, or do this only if you have no other choice. So let's say we have a list model. We're going to call it list model. That's going to be the model for histogram. And normally, well, this model, you have list elements, and then you say that bin number is 0, and then red count is, I don't know, whatever, green count is this, and so on. But we're not going to do this by hand. We're going to actually use the histogram we have here. So instead of adding these list elements like this, we're going to add them programmatically. So what we're going to do is that once the histogram has been updated, we're going to clear first the model, right? So we clear the model. Then we iterate over the histogram. Over all the bins in the histogram. And then we create an object here. So the bin number is going to be I. The red count is going to be a histogram red count. The green count is going to be our histogram histogram green count for the current beam always, and finally the blue count. And once we have this object, we just append it to our model. Oops, sorry. Oh. So notice how we have these four different entries in our object, and this actually is the role that we are the roles that we are going to assign to each of our columns in our table view. So the first column's role is going to be bin number. Second column role is going to be red count. The third column green count, and last column blue count. Okay, and let's not forget assign the model to the table view.
It wouldn't look very interesting if we didn't actually assign the model, would it?
Yeah, I think it will stay as sad as it's been so far. So let's see. Let's open a file, and magic. We have some data. So, but this, as I said, well, we can see the same as before, that if we resize, we change the bin count in our histogram, then the table view changes. If we change our image, the table view data changes as well. So this is working. But as I said, this is a hack. This is really if you need an ad hoc solution, if you really quickly need a model and you don't have time for it, or you want to test something quickly. As you can see, it's barely a dozen lines, and it works. So what we're going to do now is do the real thing. We're going to create a real model. So what we want here instead of a list model is what we're going to call RGB histogram model. And our histogram model will need a histogram. And probably we don't need this anymore. Well, not probably, for sure. But okay, so why do we have this, and why do create a new object, and why don't we just assign to our table view? Let's see our table view here again. We can say, why don't we modify our histogram so it can be the model? Well, it will sum up to this. So this is our histogram. We know it inherits the object and has some API. We're not going into data. But if we want this to be a valid model in QML, we will need to do some changes. We need it to no longer inherit QObject, but for instance, QAppSideList model, and then add some extra API, because AppSideList model being an abstract class, it demands that we implement all this. Well, the role names we've seen, we interface how many rows we have in our model, all the data. But this brings API bloat on first. Second, maybe you don't own this RGB histogram and class in itself, so you cannot go and just modify it. So we really discourage people to do that. Don't do this. What you want to do is, we have this C++ object, in our case, is the histogram. And we want to use the proxy model. So we will create a QML, a C++ class that is going to be a QML model, or is going to be seen as a QML model, QML. And so once you have your table view, you are going to, you can assign this directly to the model. API-wise, it looks like this. In C++, our RGB histogram is untouched, and we just add a new class. And this new class will have a property histogram that's going to refer to a histogram, and then we can implement what we want. So this is what we're going to do. So let's create a new C++ class, call it RGB histogram model. Base class is Q abstract. This model ingress Q object, blah blah blah. All this is good. Put in the right place. Continue. Done. Again, so what we want here is our property. RGB histogram and let's call it histogram. And so on, and then we would need to implement all the methods that QAbstract model demands. But as you have guessed, we have done this before, so we have it here. Let me just copy paste this here, and here it is. So we have a histogram property. The roles, this is how they are made public. We do this visible in QML. You have to define these role names. Well, I will urge you to refer to the QAbstract list model documentation to see what is going on here. But it's pretty straightforward. The interface is very thin. When we set, for instance, when we set the histogram, so we wait until the histogram has been updated, and then we update. We call a slot that will update basically our model. It could be updated in a smarter way, hopefully, but for our purposes, it's good enough. What else do we need? Oh, I need to fix this. Get a thing here. Okay. So, and last step, we need to make our histogram model visible in QML. So we're going to do basically the same we did for our histogram. We're going to interface it. Let's put it in the same module, why not? And histogram model. And our histogram model should be visible in QML. Remember, it's the same import statement, so that we don't need to add anything. And here, histogram model. So let's give it a try. Let's open a file. And there it is. We have a histogram model.
Very nice.
Very nice, indeed. Notice that we didn't need to change anything else in the table view. We started with a QML compatible model, and we continued with one. We just switched. We just went for a hopefully smarter implementation, or more efficient in some ways. But we didn't need to change anything in table view. So that's a good thing in QML generally, and also that we try to replicate in QP controls, is that we keep things as compatible as possible. And so yeah, let's see now this histogram view. Well, let's go back here. Let's open an image. Let's open this one. Our histogram view is working as usual. We haven't touched it. It's using still the previous API. Remember that histogram model. We just added histogram model. It was working already. So let's see a bit its definition, how it's implemented. well, you see it has a histogram property that's mainly its API, and then the implementation is relatively straightforward. There's a row and a repeater inside it, and then a rectangle for each channel, and that's it. It doesn't need anything else. Let's change it so that it can use our histogram model. So histogram model, so the property and no value so far. This histogram here, we don't need to make it a visible property. Well, it can stay there, but let's say it's just a reference to a histogram model, histogram. Our repeaters model is going to be a histogram model. And as you can see, for each rectangle, the height depends on our histogram red count of index, but this we don't need anymore. We can do this and use this red count role here. Same for green count, and same for blue count. So that's some little changes we've made to our histogram view, and then we need also to change the interface. We change the interface as well. So let's give it a try. It's open. Image, and our histogram view is still working. So you can see that if you think properly about your API, you can adapt very easily from, let's say, ad hoc API to our model API, and this conveys very strongly the MVC pattern, model view controller pattern, or maybe it's not exactly that, but the idea that you can have really a single model and different views for it. Also notice that how little code we had to write. It's barely 120 lines. And we have our complete UI, right? Remember that first slide we had? It's exactly as it should be.
Very nice.
Very nice.
I think this is a very good example of how little code you actually need to achieve what you want in QML.
Exactly. Yes.
I also have a couple of questions from some of the listeners, Gabriel. Do you need to implement the clear method, or is that actually in the object list model?
Let me see. This is an RGB histogram model, right? The clear method, it could be, but not in this case. Not in this case, but maybe you have, again, you may have smarter ways of doing this. So this is a very dumb implementation. It's not necessary.
Okay, yeah. And there's another question that QML applications seem to contain a lot of descriptive code. Can QML applications be split into a kind of module? I guess that's a little bit what we've already seen, that you can do the implementation both in C++, but also in QML, and you can easily split it into different files.
Yes, what we recommend is use QML for what it's good for, and what is very good for, as we have seen, or we can see in this example, is to do the UI, and then bring in the logic from C++ little by little, and use these small bricks to give sort of life or bring data into the UI, right? So yes.
Very good. I'm also curious, we've seen a little bit of the QML components right now. We've seen some split views and some tab views, etc. But are there more components available in the Qt components library?
Yes, obviously. I'm going to run you this Qt controls gallery. Where is it? Here. Obviously, we have all components. You can see we have buttons, text boxes, radio buttons, text areas, you name it. We have everything. It's not yet as complete as widgets are, but we're getting there, and we really recommend give it a try. You can do pretty serious applications already with what you have.
Exactly, exactly. And now you're obviously on the Mac, and these look very native to the Mac platform. But all of these components will look native on Windows and Linux as well, I guess.
Yes, again, this is Qt. So one of Qt is a two-headed dragon, so to speak. The first head is easy development. We try to make APIs so that developers can use our controls easily. The second head is cross-platform. So yes, it works on Mac, and it works as well as Windows and on Linux.
Exactly, exactly. But as you said, there might be some things missing, or you might want to have very special use cases, or want to have your completely custom controls or things implemented yourself. Is that something that's possible to do in QML?
Yeah, absolutely. Actually, most of the controls are, or the QQ controls module, so to say, most of the functionality, most of the features, I would say about 90% of them are implemented in QML. We have some C++ because there are some things we want to do faster, maybe. But yes, go ahead, implement your controls. You can style them and so on.
And I've also gotten a question here about multi-screen or multi-windows, whether Qt can support running an application over multiple screens. And I think, for instance, Qt Creator that you've been showing today is a good example of that. Now, it's going to be difficult to show multi-screen over the webcast, but Qt Creator is obviously a Qt application in itself. It's a very good demo of how you can use the APIs. And in Qt Creator, we also have multi-screen support so that you can, for instance, view some parts of the UI of the application as a separate top-level view that can be on a different screen, so that you can utilize having two screens when developing the code.
Yeah, we completely support that. This is before Qt control. This is the part of the core of Qt.
Exactly. So yeah, let's see. Yeah, I think there's also a question regarding mobile, if the Qt Quick and the Qt Quick components can be run on any of the mobile platforms.
Well, actually, yes, they can. We're still a bit short on the styling because, as you know, we're working a lot on mobile and embedded, but we're still a bit, let's say, young in this department. So we're still missing styling. Also, Qt controls come with a base style, completely implemented in QML that you can customize to your will. And so yes, Qt controls work on mobile, and Qt Quick itself works on mobile and embedded without any issue. And we're we are working on having a proper Android style in the 5.4 release. So that shows that it is going to be a way for us to saying that, yes, please use Qt controls, and you can use them as much as you can.
Mm-hmm. And yeah, there are some questions regarding embedded as such, and I think it's just to point out that Qt as a C++ framework being cross-platform would work. The application would work exactly the same way also on an embedded platform such as the IMX6. That is a platform that we do support out of the box with our Qt Enterprise embedded offering. You can run these demos out of the box on devices such as the IMX6, the BeagleBone Black, the Raspberry Pi, etc. And there is no difference you need to make in your QML or your Quick code or your Qt code. Qt Creator also comes with a number of kits which is something we've covered in a different webinar. And you can very easily use these kits to cross-compile and deploy to embedded devices.
Mm.
Exactly. Yeah. And with that, I think we're approaching our 1 hour limit. There aren't that many more questions. Feel free if you have more questions. For those of you who joined not at the beginning, don't worry. We have been recording the webinar, and we will be sending out a link to everybody that signed up, so you can download the webinar after the session. It will take some time, so sometime tomorrow we'll send out that link, and everything should be available to you then. Yeah, and feel free also to contact us with questions afterwards.
Yes, whatever you need. You can, and also you have ideas for other Qt controls or whatever. Don't forget that Qt is also an open source project, so you can contribute and come with whatever you need.
Yeah, absolutely. That's a very good point, Gabriel. Okay, thank you very much for listening, and still have a great day, everybody.
Yeah, goodbye.
Goodbye.